Hello everyone. Today we will discuss about the distributed acoustic sensing technique. This is also called DAS. This DAS technique is used for pipeline monitoring, well bore monitoring, earthquake detection, subsurface imaging, flood monitoring, perimeter security, railroad monitoring and traffic monitoring. In the subsurface mapping, here you can see the fibers are inserted in the borehole uh, along the depth as well as the horizontal direction. As I have mentioned, in DAS the optical fibers are used, which is a continuous monitoring source of acoustic signal flowing through it. This optical fiber is used as a large number of seismic sensors to record the wave field. This distributed acoustic sensing technique works in 4 stages. First stage is laser pulse injection. Second is detection of the back scattered light. Third is the interpretations and analysis. And fourth one is the continuous monitoring. For installation of the fiber cable in DAS techniques, the ground is excavated and a PVC where the fibers cable are inserted is placed at a particular depth. So generally it is placed at a depth of 1 to 2 meter and the diameter of the optical fiber cable is 10 to 15 centimeter. Inside the optical fibers there are multiple number of glass chips are there which are randomly distributed, and when the coherent laser pulse is inserted inside the optical fibers, so their positions are varying with respect to the how the sense signals are coming, and back scattered response are gathered at the particular sensing location. So we can obtain the position of strain changes along the fiber length. There are few advantages of distributed acoustic system, as it is not using the predetermined points, so the signal is gathered along the continuous location. It will also measure the real-time signals, and we can operate it from the remote locations. Let us understand the difference between the distributed acoustic system and multi-channel analysis of surface wave MSW techniques. If you are not aware of MSW techniques, so we have uploaded a detailed video on our YouTube channel, so you can go and watch there and understand how it works. In DAS, backscattering of the light along an optical fiber cables is detected through the acoustic signal. However, in case of MSW technique, propagations of surface waves are measured by the geophones through the active and passive MSW technique. In DAS, subsurface imaging can be performed for the entire length of the optical fiber cable. However, in MSW, the depth of investigation is limited to the 30 to 50 meter in an effective manner. The depth of investigation in DAS also depends upon the cable installation's depth and the property of the surrounding medium. In MSW technique, the depth of investigation is limited to the frequency range of the dispersion curve. In DAS, the signals are acquired continuously along the entire length of the optical fiber, and there are specialized equipments and similar processing tools are there to analyze the data set, so it will require the advanced analysis procedure. In MSW techniques, we record the data and do the analysis in frequency domain for the dispersion curve analysis and invert this data to estimate the shear wave velocity profile.